I'm Luca Franco.
I'm Ali Sidley.
The Higgs boson was discovered at CERN in 2012, and since then, particle physicists have been wondering if that particle was really the standard model Higgs boson or another particle very similar to it. The actual way to answer it is to measure its properties with the highest precision possible. Among the many properties of the Higgs boson, the strength of the coupling to itself, it's one of its properties that is still experimentally unconstrained.
At Atlas, we are searching for, among many other things, di-Higgs events, so decays in which a Higgs boson decays into two other Higgs bosons. And this way, we are sensitive to the self-coupling that we would like to measure. In this paper, we are looking for di-Higgs decays in which one of the Higgs decays into a pair of bottom quarks and the other one decays into a pair of photons. For this paper, we used the full Atlas Run 2 data set, so all the data that was taken during the years of Run 2. And then we do a selection of di-Higgs events using some machine learning in order to reject the background and keep the events that are most likely to be our di-Higgs signal.
And then the events are used to reconstruct the invariant mass of the system of two photons, which is then used to extract the final result. The signal manifests itself as a narrow peak over a continuum smoothly falling background, which is a very characteristic sign of its presence. In order to study the self-coupling, what we do is we measure deviations from the standard model prediction. Anomalous values of the Higgs self-coupling would enhance the production rate of the di-Higgs.
So the self-coupling parameter represents how likely this di-Higgs process is to occur. A larger self-coupling means there are more di-Higgs events present. So this plot represents the results of this study. If you look at the yellow ellipse, this gives us the best limits to date on the value of the Higgs self-coupling modifier kappa lambda. And for the first time, we have constrained not only kappa lambda, but also the value of another coupling, the coupling of two Higgs bosons to two vector bosons. And this can be seen on the y-axis by the vertical shape of the ellipse.
What we did in this paper is only the first step, but in fact, with upcoming data set that we expect to collect with the next LHC runs, we can improve our constraint on the self-coupling and hopefully exclude the value of 0 by the end of run 3. On the other hand, if we want to actually observe the Higgs production, we have to wait for the end of the run 4, which is where the Large Hadron Collider will operate at high luminosity.